EESIM's DC-to-DC converter design tool creates and simulates switched-mode power supply circuits based on a user's specifications and preferences. The built-in intelligence and straightforward interface enables novice power supply designers to work with speed and confidence, while advanced features enable experienced engineers to develop a finely tuned circuit. This video provides a brief tour of the most essential functions in EESIM. For more detailed information and instruction on EESIM's many capabilities, refer to the EESIM user manual or the how-to video series on the help page. There are several ways to begin using EESIM. From the Maxim website, activate the Design menu and navigate to Design Tools. To design with a particular part, visit its Product folder and look for a Tools and Models option on the right-hand side of the page. EESIM requires a simple registration through the Maxim website, which you may already have. If you have not previously registered or are not logged in, follow the prompts on the screen. Once inside the EESIM environment, there are 3 different ways to open a DC-to-DC converter design. Click the Browse Designs button to select from designs that have been built in hardware and tested by Maxim's engineers. Click the Enter Part Number button if you have already selected a Maxim device to work with. To choose a device by filtering on voltage, current, and other specifications, enter your design requirements in the provided boxes and click the Search button. This demonstration will use the MAX 15058. After clicking on MAX 15058 to start a new design, observe the Design Requirements page. Every field is preset to a reasonable value. Adjust these default values as needed to meet your requirements. Be sure to indicate your priorities concerning design size, efficiency, and cost. Click the Create Design button to generate a unique design based on these requirements. After all the design equations are calculated, the Schematic tab opens displaying the circuit schematic. From here, components can be changed and the circuit can be recompensated. However, it is a good practice to save the design before making changes. Click on the Save button in the upper right corner and give the design a meaningful name. Once the design is saved, its name is visible in the upper left corner of the screen. Note that the key properties of each component have been calculated and are displayed on the schematic. Right-click on a component and then click Properties to see the commercially available part EESIM recommends based on the calculated values. The manufacturer and part number are prominently displayed. A different vendor part can be selected by clicking on the Select Vendor Part button. The parts initially displayed have been filtered to satisfy the calculated component properties, so any of them will produce the specified circuit performance. Just click on a part to select it. Certain components, such as input capacitors, output capacitors, and the inductors, are considered critical components because a change can significantly affect the performance of the circuit. Critical components are identified with an orange banner. To change a critical component, either select a different vendor part or define the part yourself. To define your own part, click on the User-Defined Radio button and enter the desired properties. After one of these components is changed, its value should be locked and a recalculation run. The recalculation adjusts the unlocked circuit components as needed to recompensate the loop and produce the desired performance. As changes are made, the schematic can be marked up with highlights, text, and other annotations. The schematic toolbar also offers tools for panning, zooming, and exporting the schematic. A powerful way to track changes is the history control. Each time components are changed, a new design version is automatically saved. Earlier versions of a design can be saved as independent designs, or rollback can be used to delete newer versions and revert to an earlier version of the design. To simulate the current design, click on the Simulation control. The Simulation Setup window consists of tabs for each available simulation type, plus global controls on the right-hand side of the window. Begin by clicking the tab for one of the desired simulations. All of the simulation settings have default values, which are generally appropriate. It is not necessary to change any simulation settings, but if desired, simply delete the default value and type the new value. Note, the load setup and line transient setup include a graph of the waveform, which updates in real time if the pulse settings are changed. After reviewing the simulation settings for each desired simulation type, ensure those simulations are checked on the right and then click Run Simulations. When the simulations are completed, results are viewed by clicking the links which appear in the upper right area of the window. The simulation results are viewed in a tool called WebScope Waveform Viewer, which groups the results into tabs. WebScope includes dozens of features which enable a thorough analysis of the simulation results. Some of the most frequently used controls are found on the left-hand toolbar. It includes controls for panning the image and also zooming in and out. On the right side of WebScope, a legend identifies each trace and also controls the trace colors, what order they are displayed in, and if any are hidden. Two important controls are on the graph itself. First, vertical and horizontal markers can be positioned on the waveforms to accurately read the data values. Second, right-clicking on the graph reveals an advanced menu used to customize almost any aspect of the graph. When the graph is the way you want it, save your results using the left-hand toolbar. Options include downloading the graph in a variety of file formats, copying the image to your clipboard, or including it in your EESIM report. At the bottom of the graph lies one more valuable tool to analyze simulation results. By default, this table shows the numeric values associated with the current marker positions, as well as the data between marker positions. The drop-down menu above the table offers many other useful calculations, such as peak-to-peak and RMS. After closing WebScope, simulation results can still be accessed from the Simulation Setup window. After closing the Simulation Setup window, simulation results from any design version are accessed from the History menu. When more than one version of a design exists, a time-saving method of comparing two design versions is the Compare tab. It compares the most recent design version with the version chosen by clicking on History and then Load. The results can display only the difference between the two designs, or the complete design requirement and BOM information for both designs. If simulations were run for either design, thumbnails of the results are shown on the Compare tab. Double-clicking a thumbnail opens that simulation in the WebScope Waveform Viewer. If simulations have been run for both design versions, the resulting waveforms can be overlaid. When work on a design is complete, all pertinent information is presented on the Report tab. Checkboxes are provided to exclude or include each report element from each design version. This enables customized documentation of your EESIM design work. To order samples of the Maximize-C or buy an EV kit, use the buttons at the top of the report. The customized design report can be downloaded from the Report tab or the Download tab. Also available for download from the Download tab are the Bill of Materials and the simplest schematic of the current design. The schematic may be used in a licensed version of the Simplest Symmetrics simulation tools, or in the Simplest Symmetrics free demo version, or in the free downloadable version of the Simplest Symmetrics tools available on the Download tab. This has been a brief introduction to the extensive capabilities in the EESIM DC-to-DC converter design tool. Create your own DC-to-DC converter designs using EESIM to discover how fast and straightforward power supply design has become. To learn more about EESIM's powerful features, consult the user guide or visit the EESIM help page.